Hello everyone, my name is Stawin Revano, and in this video I'll be talking about the research that I've done with my partner Gilbert Nicholin, supervised by Professor Alexander and fellow Chandra PRADANA, with the title being Prompting Strategy versus Model Selection, a comparative study of open source LMS for misinformation detection. So as we know in this era, misinformation is basically everywhere, and the problem isn't just that it exists, but it also spreads really fast, faster than we can manually detect it. So a lot of people have been asking like, how can an AI do this for us automatically? Which the answer is yes, but the main problem is that whether does the model that we choose matter more than how we instruct it? So as we know, misinformation actually have caused a lot of harm in a lot of sectors in our life, and that's where large language models, or as we know as AI, can classify news articles as real or fake ones through prompting alone, without any training data required, because it was already trained beforehand. But the problem is that existing open source LMS benchmark rely exclusively on zero-shot evaluation. Zero-shot is actually a prompting strategy that we're going to talk about later. And that leaves the effect of prompting strategy largely unexplored, which brought us back to our main question: does the prompting strategy or the model selection matter more when deploying open source LMS for misinformation detection? With this, we want to identify whether the model or the prompt produce greater performance difference. So here's the visual chart of our methodology. So the model that we're gonna use is actually three. The first one being Mistral 7B, which have around 7 billion parameter. Llama 3.38B, which has around 8 billion parameters, and Pi 3.5 mini, which has around 3.8 billion parameters. So it's basically like pretty lightweight. So we can run it on our pretty mid-range device, let's say. And we're gonna run those model with three prompting strategies. The first one being zero shot. Zero shot is basically a very simple one-line prompt, and then there's few shot. Few shot basically a prompt where we're gonna provide an example for it. So in this case, we're gonna give three real and three fake articles as examples, and tell the model to identify the articles that whether the articles that we wanted to identify as real or fake one. And then the last one being instruction tune. Instruction tune is actually like a very detailed prompt. So we're gonna give it a guide how to detect the fake one and how to detect the fake one. I mean the real and the fake one. But in this prompt where we don't provide any examples. And the data set that we're gonna use for this is the welfare articles that can be accessed through Kaggle, and we're gonna use 2,000 articles, with half of them being real and half of them being fake. So it's a balanced number. And the metrics we're gonna use is accuracy, F1 scores, and output. So here's the result. There's two main chart. We're gonna start from here. So this is basically the accuracy and the accuracy across all of the model and across all of the strategies. And also, I want to mention that the scores of accuracy and the scores of error that we gain in this experiment is actually the same. So you guys can actually see this accuracy as our one, because it's basically the same value in this experiment. So as you can see right here, there's three chart bar with the purple one being the Mistral one, the green is Llama, and the orange is the Pi 3.5 mini models. And as you can see right here, Pi 3.5 mini actually have a very high accuracy compared to the other two models. It shows that it's actually superior compared to the others. And also from the strategy, we can see that the fusion actually have a very higher scores compared to the other strategies, especially in the Llama one. As you can see right here, it has a very significant jump in accuracy value. But on the other hand, Mr. have a overall pretty bad performance compared to the others. And here is the macro F1 score heat map. This basically show the F1 scores across all the models and strategy. With the Pi 2.5 mini have the highest F1 score overall, and the other have a pretty decent one. But as you can see right here, Llama actually have pretty high scores in the few such strategies. It had like around 18.7% increase in its value, which shows that how good the few shot strategy really are. So here's the finding that we got from our experiment. The first one being model choice dominance. So as you guys can see right here, the Pi 2.5 mini, despite having only 3.8 billions of parameters, have a very significantly high scores in accuracy and the other scores. So that basically shows that the model that we choose matter more than the strategy that we use. Second finding is that, sorry, the second finding is that the field shot strategy have the most effective, is actually the most effective strategy. It's because as you guys can see right here, it has a very high value compared scores compared to the other, especially on the Llama one. The last one is Mitchell 7B actually have a label bias, and it basically the reason why the his this model's performance is overly bad compared to the other two. The conclusion is that model selection matters more than prompting strategy for open source information detection. Pi 3.5 Mini is the recommended deployment choice given its consistent performance across all conditions, while Llama 3.8b requires few sub-prompting to reach its full potential. The session-tuned prompting behaves inconsistently across model families and should always be validated before deployment. These findings offer practical guidance for organizations building detection systems without access to commercial APIs. So that's all for this video. Thank you very much for watching.